Today we're going to continue with ratios and proportions. This standard RP2A, we're going to deal with, is it proportional? So does it fit y divided by x? Is it the same every single time? So let's start with problem 1. Is there a proportional relationship between x and y in the table? So let's just say y divided by x every time. Well, for this one, we're going to say 2 divided by 5, which is 0.4. For our next one, 4 divided by 8 is 0.5. Notice that I'm getting different values. So no, it is not proportional. These are different. Number 2, the table shows the number of red flowers and blue flowers in several different bouquets. Are the quantities proportional? So let's just start dividing out y divided by x. So for this first one, I'm going to use x for red and blue for y, and say, okay, 9 divided by 3 is 3. Now for this next one, 15 divided by 5 is 3. And for our last one, 18 divided by 6 is 3. So are they proportional? Yes. There are always 3 blue flowers for every one red flower. Number 3, select all the graphs that represent proportional relationships. Now, if they're proportional, we're looking for 2 characteristics. Number 1, it has to be a straight line. Number 2, it has to go through the origin, which is 0, 0. So looking at each of these, the first one is a straight line. It goes through the origin here at 0, 0. So yes, it is proportional. The second one is not a straight line. So no. Our third graph is a straight line through the origin. So yes. Our fourth graph is a straight line, but it does not go through this point, so no, it doesn't work. And our last graph, it is a straight line, but it does not go through the origin, so it doesn't work. Standard RP2b. On this standard, we're finding the constant of proportionality. That is where we take y divided by x, and we call that number k, the constant of proportionality. Let's start with problem number 2. The values of the table are in a proportional relationship, so what is the constant of proportionality? So we're going to say y divided by x to get k. In this case, let's take 24 and divide by 6, we get 4. Let's take 32 and divide by 8, we get 4. We should get 4 every time, and I'll tell you that there is a typo here. That last one should be 12 over 48. But we do get the constant proportionality, C is 4. Number 3, a graph has this equation. What is the constant of proportionality? Well, actually, K fits into this little equation, y equal K times X. And in this problem, it's y equal 2/3 X. So K is 2/3. Number 4, the graph shows a proportional relationship between the number of batteries and the number of packages sold. What is the constant of proportionality, and what does the constant of proportionality represent in the situation? So we know that we get the constant proportionality K by taking y divided by x. In this case, we've got this ordered pair where x is 4, y is 1. So 1 divided by 4 is K. And then what does this represent? Well, we know that x is the number of batteries, which is 4, and y is the number of packages, which is 1. And that says that each one package includes 4 batteries. Number 7. A graph has the equation y equal x over 8. What is the constant of proportionality? Well, we could actually rewrite this equation. When we have a variable in the numerator, There's an invisible 1 in front of it, so this is 1/8, and we'll pull that fraction out in front of x. So the constant proportionality k is 1/8. Answer choice B.